right. Hopefully there's not a bunch of stuff on there. Okay. So it kind of makes sense. The reason we created this is because we understand that we normally don't know mu. So we started with this dude, and we messed with it until we got here. That's what we did. And we started with this dude again, and we messed with it until we got to the p-hat formula. Fantastic, I love it. Because this is the basic, this is like a definition of z-score. So I can start here and kind of mess with it to develop certain things for different situations. So it kind of makes sense. We normally don't know this shit. We only know this. But then what goes along with that is what I said earlier. We normally don't know this either. There are situations where we will, but there's a lot more situations where we won't. Right? Some asteroid comes by. We send a rocket ship up there to see what percentage of that asteroid is a certain material. We don't have a clue going in. We take samples. We're not going to get any freaking population information. I don't know. Shit. So, what I talked about last time was an idea that makes a lot of sense. If there's a piece of this I don't know, so the last piece I can kind of replace with an estimate is this. If I have to put an S here, become an S. Sure. If I have to approximate sigma with S, what should happen to my confidence intervals to still be whatever percent confident? So if there's a fish that I want to catch, and I think it swims this much, but I'm not sure, to catch the fish, am I going to make my net bigger or smaller?
Bigger.
Bigger! To cover my ass for the thing I don't know. So there's going to be, this is what's going to make a ton of sense. It should. Is there's going to be another score that I'm going to put here, a different score. And let me just tell you what it is so I can actually point to it instead of a blank space. It's going to be called the T-score. And I know already, I can just feel you guys going, what the f? But what should make sense about that T-score? Should it be bigger or smaller than an associated Z-score? We just figured out the interval should get bigger, so my error should get bigger, so this T-score is always going to be a little bigger. But should the T be a certain value forever? No, because when am I going to trust this more? When would I trust this more if the sample I take is bigger? Okay, so stay with me. So the T-score will always be bigger than the Z-score in that same situation, but it will get smaller and smaller as n gets bigger and bigger. Because I'm going to need it less and less. If I take a really big sample, I don't have to cover my ass that much more. Because I feel better and better about this. Okay, I like it. So there's two things right there. If I bring this guy in, something else has to be put here. So like an adjustment to this. Okay, that's that. And then something else I want to bring in right now, because I always forget to bring this in. Anybody remember what this, well, let me write it like this, because you haven't seen it like that yet, I don't think. Degrees of freedom. We talked about that earlier, right, this semester? Anybody remember that? Did my horrible Braveheart, degrees of freedom. You can take away. Sorry. Now, real quick, we remember degrees of freedom was, the discussion we had was because this formula had an n on the bottom and this formula had an n minus 1 on the bottom. Does that sound familiar? Remember that? So this formula was this guy. This formula was this guy. No, yes? No, yes? You remember that? I'm going to pretend like you do, because it happened earlier this semester. It wasn't that long ago. And we had a discussion about, a little bit of a discussion about why this might be n minus 1 instead of n. Okay. So we already discussed, I try to do this ahead of time, so when we got here, it wouldn't be that big of a shock. So it kind of makes sense that this is going to show up again here, because I am taking a sample. And I am using S instead of sigma. So let me give you this chart, and then we have to focus on just how the hell to use this chart. This chart is actually much easier than the Z-score chart, and that's not that hard. You get Andres. All right, so we wake this dude back up. Do you guys see that? Normally where the sample size is? Well, all right. Running down are the degrees of freedom. That's where you might expect the sample size to be, because like we said, as the sample gets bigger, the t-score should get smaller. So let me deal with a situation we've seen a few times already, just so you buy into this a little bit. By the way, something I neglected to talk about was the history of this. Anybody drink Guinness at all? Anybody like Guinness a little bit? What got me through physics? You'd go get some Guinness with the physics professors, and they would, we got them a little bit drunker, they would sometimes tell us what was going to be on the test. It was great.
Does that work for you?
No. When are you going to try? I don't remember shit, so you're not going to get anything. So there's this guy, William Gossett, who worked for the Guinness Brewery. Another word, brewery. And he did some analysis trying to figure out, to be honest, I can't remember the exact thing he was looking at. But he developed he developed this T-score. He developed this because he realized he was taking samples for which he had no idea what this should be. So he developed the idea of this T-distribution. He created it. He submitted it under a pseudonym. So you'll hear this called the student's T-distribution because he submitted it under the name student. Because Guinness would have owned his work, because he worked for Guinness and he did this in terms of Guinness, if he would have let them know that he did this. And he's like, I don't want Guinness to own this. I just want this to be out there. You guys kind of follow a little bit? So it is interesting. It has some bases in Guinness. Depending on the class, sometimes you get a lot of interest when I say, oh yeah, this is based in Guinness. I'm like, what? So let's take a value that we know already. 1.645, right? You should know that number 1.645. It should have come up a few times already. It's related to a 90% confidence interval. Now, one thing to get over about this chart, notice on the top how it's broken out. It's broken out like that, to be honest, to help us with Chapter 9. In Chapter 9, we're going to thank the gods that they've broken it out like this. Because in Chapter 9, we're going to be testing claims. And if I say, I think the mean is actually bigger, then that's just going to be that upper tail, that one tail. But how many tails does a confidence interval always make? Yeah, so if I want to be 90% confident, how much is outside in the tails? How much is out? If there's 90% inside, there's 10% in two tails. So look, area in two tails. 10%. If you accidentally cut that in half and say there's 5% in one tail, you're in the same stupid column, you're fine. I like it. Notice what's happening. If my sample size is stupid small, how big of a sample is this for this first row? The degrees of freedom is what? What's the formula? That's right, kids. N minus 1. Right? Like we just said a second ago. So for that first row, how big of a sample is that? What's N? If degrees of freedom is N minus 1, and that's a 1, N must have been 2. Okay, so that's... And look how big the freaking T-scores are. They're huge. But look at the bottom of that column. This is related to the 90% confidence intervals. Everybody cool with me saying that? That's 90%. This would be 80%. This would be 95%, blah, blah, blah. What's at the very bottom of this column? 1.645. And look what sample size is that related to. Some of you guys are going to love this. Large. And there's a lot of reasoning behind it. In most math courses, large is subjective to a situation. Okay. But you can already see it's not changing much once it's up to 2,000. So the smaller your sample is, the more necessary it is to cover your ass more and more. So the T-score I'm going to use gets bigger and bigger to cover my ass a little more and more. So that's awesome. So notice this though. This is a T-score chart, right? But if I need a Z-score, I'm going to use a stupid chart also because the bottom row are Z-scores. And look at them all. 2576 is actually a little bit more precise than the 2575 we were using earlier. You guys with me? But that would be for a 99% confidence interval. We saw that twice today, right? And then you got 2.33. I don't know if that's come up yet. That's a 98% confidence interval. 1.96, we've seen that a few times. That's 95% confidence. Are you guys with me? So I will repeatedly say this. I will bring this chart out to find a Z-score, and somebody will say, what are you doing as a T-star? What are you looking at? So freaking Z-scores live down here, right? The need for a T-score becomes less and less the bigger my sample gets. And if my sample is large enough, I can just go ahead and use a Z-score. Large enough is a little subjective based on how precise you need to be. That's why they made it this way. You guys kind of with me?
Is this for a normal distribution?
Beautiful. I love it. So in order for T-scores to work, just like Z-scores, they require a normal distribution. Yeah. So I'm going to say this next thing over and over. So it sounds like a note. You write, you put a box around it. Why were T-scores invented? To cover my ass for not knowing sigma. That's it. So when am I going to use a T-score? Two things. If I don't know sigma, I only know S. I have to use a T-score. Secondly, it's got to be normally distributed. That's always got to be true for me to do anything. I love you guys. You will see what I mean when you get into these problems. T-scores were invented to cover our ass for when we only know S. We don't know sigma. So when am I going to use a T-score? When I don't know sigma and when it's normal enough. If it's not normal enough, it can't do shit. I want to get. So let's find some T-scores for different situations, and then I got a handout for you. By the way, so we're going to find some T-scores just to make sure we know how to use a chart. But what does the formula become now for this situation? If sigma is known and is normal, get out of there. Then I can use this formula here. If S is known, sigma unknown, and is normal, then I have to use this formula here. You're going to have both of these formulas on your formula sheet. So these are notes. When do I use T? Oh yeah, when I know S, these go together. I mean, so Z goes with when you know sigma. T goes with when you only know S. Formula tells you. Formula tells you. So let's try a couple of T-scores. And then I'll shut up and let you guys work on the worksheet. So let's say that N is 51, and I want to be 95% confident. And sigma unknown. What would my T-score be? Try to figure it out from the chart. So how do you do that? What area is in two tails for 95% confidence interval? What area is outside? 5%. So the area in two tails is 5%. I want this middle column. And where am I going to stop? What's my degrees of freedom? Sorry, I got to say it that way every time. What's the degrees of freedom? All right, I did it with 50. Yeah, 51 minus 1 is 50. So if I go to a column and I stop somewhere, that's a T-score. If I go all the way to the bottom, that's a Z-score. So I'm going to stop at 50. And what T-score do you get? 2.009. So I would put that in the confidence interval formula. Instead of putting 1.96 for a Z-score, I would put 2.009. The formula is basically the same. I'm just putting a score that's a little bigger than the Z-score I would have used. Please let that be so nice. All right, what about this? So that's T is 2.009. What if N is 6? Sigma unknown. And I want to be 98% confident. I'm being a little bit evil. Can you tell me the T-score you would use? Let me answer that for you. No, you can't. What's missing? Why can't I use the T-score chart? Why can't I do shit for this? Yeah, why was this first one normal? I didn't even say anything about it, but why was this first one normal enough? N's greater than 3. I like it. Here, no. So what I have to say it's normal enough. Not nominal. Now you can tell me what the T-score is going to be. So which column are you looking at? Which one? 98% confidence, so how much is in two tails? 2%. So I'm going to stop at what? What's my degrees of freedom? 5. So there's the T-score you would use in the confidence interval. The formula doesn't really change. It really doesn't. I just put this number in instead of the Z-score. So 3.365. Okay, I think you're ready. I think you're ready to do this because it's not graded. Some of them are green because green paper was in the printer before I realized it was different color paper. So I'm just like a month off for that. Especially spring green.